Hello friends, we will see how to design 4-bit binary to gray code converter using Tinkercad. Okay, very first it is very essential that you must have your Tinkercad account. Okay, for that how to log in, that we will see now. First of all, if you if you are a first time user of a Tinkercad, then you just type Tinkercad in Google and Google it, and you create your account. So if you have your account, then you can draw the circuits and you can perform experiments uh, in digital circuits and analog circuits by using Tinkercad. Today I will explain you how we can perform these experiments using Tinkercad. So I have already my account login over there in this Tinkercad. Using this Tinkercad, how we can perform various experiments by building the circuits over there. Now here in this Tinkercad, various options are there, like you can do 3D designs over there, then you can draw their circuits over there. So various components like breadboard, power supply, function generator, oscilloscope, everything is available there. You just have to develop your circuit and perform the experiment. Okay, code blocks is also there. So the way you want to go with, you can design your circuits and you can perform. Now since our aim is to design electronic circuits, I will explain you how we can create a circuit and how we can simulate it. So for that, what you have to do, after login, you just click on these circuits, then create new circuits. So you will get another window open over there like this, and now here you can do your task. Okay, so suppose we want to design any electronic circuits. For example, if I want to design here digital circuits, then how we can do it? So here on breadboard, suppose I want to develop my circuit, then how we can do this? First of all, I just want to introduce you which components are available over there. So if you look at here in search, various components are available. Like if you can see, battery is there, breadboard is there, DC motor, then BJT, LEDs are there, diode, photoresistor. So you can like, even multimeter is also there, oscilloscope, function generator. So whatever basic components needed to perform your digital circuit experiment or analog circuit experiment, that all components are there. Even ICs are available. Okay. So I will just demonstrate you how we can perform the experiment. For example, any basic experiment. I will just uh, help you to understand how we can select the component. Suppose initially you want to uh, get a breadboard, so just type a breadboard over here in search. Okay, so you will and click on breadboard, you will get their breadboard. You just select that breadboard and drag it over here. Okay, so you can drag it like this. Okay, now here resistor, even suppose batteries are there, so you just search for a battery, you just type over here, then battery is there, 9-volt battery, suppose I want to select. Okay, then just a minute, yeah, 9-volt battery, so you just drag it and drop it. Okay, you can select component like this. Even you can rotate this component by using this rotation option over there like this. Okay, now for this, anode and cathode terminals are positive or negative terminals are marked over there. Okay, so accordingly you can do the connection. So this is what positive terminal of battery, this is what negative terminal of battery. Okay, so this is how you can select a battery over there. Then one more component is there, like suppose function generator I want to drag over there or use over there. So I will type here function generator and you will get there. Okay, so this is what the function generator which is there. I will place it properly. I'm just giving the information how we can uh, get these components, which various components available in Tinkercad. So this is what your function generator. For this function generator, you can give the range of frequency, amplitude, offset voltage. Even you can select a various types of waveform like square wave, sine wave, triangle wave, like that. Okay. So this is your function generator. Then oscilloscope is also there. So just type a scope over there. Just a minute. So I will type here scope. Yes. So you will get their oscilloscope where you can observe the waveforms over there. Okay. So this is what your oscilloscope. Here also positive and negative terminals are marked over there. So accordingly you have to connect them. Okay. Then after this multimeter is also there. Yes. This multimeter is also there like this. So on this multimeter you can take the readings of voltages whatever is there. Okay. So the in such a way various components are available over there. Even suppose I want to use some IC, for example IC 741 op-amp IC I want to use over there. So what I will do, I will just type over here IC 741 or simply number. Okay, so I am getting a list here number of ICs in the series of 741. I needed open op-amp over there, so I will just drag and drop it. Okay, and what always you have to place your this IC at the center, and normally then do the connection whatever actually you are doing on actual breadboard and all. Okay, I will just show how we can how we can do this connection. I will show you. I will just rotate this battery over there. Okay, now this is what negative terminal and this is what positive terminal. So how to connect this battery to this breadboard and all. For example, I want to make this upper line entirely positive and this below line entirely negative. So what I will do, I will just click over there here and I will drag from this and I will extend this and draw a line over there. Okay, it shows the connection of this negative positive terminal to this particular line on breadboard. Similarly, this negative terminal I can connect, I can make this entire line as a connect to the negative potential like this. Okay, I can change the color of this wire also. So just select and here change the color of wire. I want to make it red because it shows a positive potential. Okay, and I used here black color to show here this particular negative terminal of the battery as well as it is the entire line on the breadboard at negative potential. Okay, so in this way you can connect various resistors and other components as per your circuit diagram. Okay, and you can design your circuit over there. Even resistors are there. Okay, you can place this resistor, you can change the value of resistor. Here I selected now resistance of 1k value. You can change its value 10k also. Okay, so that option is there. Now here one more thing is there. If you want to highlight that particular if you want to write some text and all, suppose so that you want to highlight some information over there, then this notes tool is also there. You just click over here. For example, I just want to r- write note about this multimeter. I just want to inform that this is multimeter. So I can write here multimeter. Okay, so in this way, if you want to highlight something, then that option is also there. You can insert text also there. Okay, now after completing your circuit, here I have drawn already made one circuit, because today we are going to see a 4-bit binary to gray code converter. So how I did that, we will see actually. Okay, so I will go to the again home screen. So in circuits, this binary to gray code converter design I have already done over there. Okay, so this is what the circuit I have already drawn using this Tinkercad. Before that, I just want to um, inform you what is binary to gray code converter. Okay, let's go to this binary to gray code concept. Here I have written truth table for this binary to gray code converter. If suppose I I gave this binary number, then what gray code I can get? Okay, so that is there. In truth table, input is nothing but your binary information, and gray code is nothing but your output. So if suppose particular binary combination, binary input is given, then corresponding what gray code I can get over there, that information is given in the form of this truth table. For example, if I insert binary number 1100, then I will get gray code 1010, that is highlighted over here. Now using K-map simplification and all, you have to design your gray code converter. So this is what the logic diagram of your binary to gray code converter for 4 bits. Okay, so what is your G3? G3 and B3, these are nothing but the MSBs of your binary code as well as gray code respectively. So similarly, B node is LSB for binary code, and G node is also LSB for gray code. Now here, if you look at, and this particular logic diagram has been derived from the information which is given in truth table. Okay, now if you look at this, we need a 7486, that is XOR gate, for the realization of this particular converter. And how it is connected, just look at this. So G3 gray code MSB we are getting directly, which is nothing but the MSB of your binary code. Okay, G2 is nothing but it is a XOR of B3 and B2 bit. Similarly, G1, it is a XORing between B2 and B1 bit, and G0 is nothing but it is a XORing between B1 and B0. So accordingly, we have to make a connection on the breadboard. Okay, so here if you look at this, I have drawn this circuit. We are using this Tinkercad and all. I already uh, inform you how to get the breadboard, how to place it, how to connect the wires, how to select this function generator or scope or multimeter. Okay, so this is nothing but a power supply. And now since we needed here 7486 IC for realization of this 4-bit binary to gray code converter, so I selected that IC and placed it at the center. Okay, now I already uh, drawn this circuit in Tinkercad. Now we can just tinker it again. So 7486 IC I had drawn. Then I took this power supply. Then positive of this power supply connected to this particular line, positive line of breadboard, and negative I connected to make this entire line negative. Okay. Now 7486 IC, it is a XOR IC whose pin number 7 is nothing but it is a ground pin. So I connected by using a wire, I connected it to this ground. Similarly, pin number 14, it is a power pin. So I connected this power pin to this particular line. So it is getting connected to this plus 5 volt supply. So here function, sorry, power supply is given over there. Okay. So after giving the supply and ground to this 7486 IC, now you have to give the inputs, and for observing output, I connected their LEDs. So here whatever blue lines are shown over there, that shows the input bits like what is B3, B2, B1, B0. That information you are getting over there, and using this here we know that it is your XOR IC. So it is in this particular IC there are 4 XOR gates are there. So you can utilize these 4 XOR gate. Actually you needed 3 XOR gate as we have seen in block diagram. Okay, so this is what our block diagram, logic diagram, we need here 3 XOR gates. So one IC sufficient because one IC consists of your 4 XOR gates. So with one IC we can perform this experiment. Okay. Now here this B3 and B2 bits I made them 1, and B1 bit I connected to ground line. So B1 is 0. Also B0 bit is also 0. So what I did, I connected this input this particular line, that is pin number 13 and pin number 12. This particular XOR gate I used with two inputs B3 and B2. Okay, and whatever its output B3 directly I have given to get a G3 to this LED. Then these two inputs I connected to this particular XOR gate, and whatever is the output I am getting at pin number 11, okay, output 4, that I am giving as a input to this particular what I can say, this particular LED. Okay, so I will just move this yes, then you can see this. So whatever is the output of this XOR gate, I gave it to the second LED. Okay, then here to this second XOR gate I gave input B1, and B2 and B1 I am XORing. So this is input of third gate. This is another input of your third gate. Just a minute. Yes, input 3A and input 3B. So what I did, B2 I have connected to this input 3B, and then input 3A, which is I have taken as from this ground line. So B2 is 1 and B1 is 0 I have given. Okay, and whatever is the output I am getting, that I gave here to this third LED. Okay, which will give you my output G2. Okay, sorry, G1. This is G3. This LED gives me G2. This gives me G1, and this last LED gives me G0. Okay, and after that one more gate I used over there with input A, input B. Okay, so this is B0 and B1. I gave to the two input pins, and output of this first gate I connected to this last LED here or here. Okay, so accordingly it gives me a G0. If you look at, this is the anode terminal of LED, this is the cathode terminal of LED. So cathode terminal of each LED I connected to this ground. Okay, so that is shown with this black color wire. So cathode terminal of every LED is connected to ground. So in this way you have to complete your circuit on a breadboard using this Tinkercad and all. And after that, once your circuit is completed, you can give the name to your circuit. So change name option is there. You can change the name, or you can give the name to your circuit whatever you design, and then you just start the simulation. So here start simulation option is there. So start simulation. Now, if you look at to this power supply, the voltage is 5.20 volt, and current which is flowing through this is 3.33 milliamperes. I purposefully connected this resistance over there. Otherwise, if high voltage is given there, then there is a chances of breakout of this IC. So, in order to avoid, I connected here one resistance of 1K value. Okay. Now, Here, whatever inputs I have given, that is code, binary code which I have given, B3 is 1, B2 is also 1, B1 is 0 and B0 is also 0. So code which I have given, it is 1100. So code which I have given, it is 1100, and corresponding to this code I should get a gray code 1010. Okay, so let's see, have we got it or not. So if you look at this, this is the G3 which has been glown over there. LED has uh, glown over there, so it is G3. This is 0, this is 1 0. Then LED G1 is also glowed over there, and this is 0. So it is your 1010. So when I gave the input binary 1100, I am getting output 1010. Similarly, for other inputs, you just verify it and you check it whether you are getting it correctly or not. So in this way, I designed this 4-bit binary to gray code converter. Similarly, you can do various circuits in this Tinkercad, and you can perform your experiments online by using this Tinkercad. Now, after completing, you just stop your simulation, and here various options are there. You can share your design with your, you can make it public, and you can share your design, you can share the link of your particular design. Okay, so whatever designs you have drawn, that is stored over there. So whatever design you will be drawn, that is there here, and you can just change the, go in the settings and see the properties, various, you can give the name to your design. Then there is a policies regarding privacy and licenses there. Okay, so you can change them as per your requirement. So in this way you can perform your experiments, and you can perform and you can verify your own designs also. So thank you for watching. Thanks everyone.